Hi, everyone. Welcome back. I'm temporarily taking over for my colleague here because Nicola asked me to. Now, settle the debate. Now, some of you heard the debate. Is this picture nice? Thank you. That's settling the debate. Nicola doesn't like this photo, but you'll see his next one and you can be the judge of that. Please welcome Nicola to our stage, who will give a talk about OpenTelemetry, something that he apparently likes to do. He also gave a talk yesterday about a different topic, but today we are going to hear this thing. And please give him a round of applause.
Hvala, dobar dan. I think this picture is much better, right? Yeah, obviously. Thanks, Eva. So thanks a lot to be at this talk. Just a word of introduction. If you didn't come yet to IPCON, you've never seen me. I'm Nicolas Fränkel. I was a consultant for a long time. I worked in different positions as a developer, as an architect, as a team lead, as a solution architect. And a couple of years ago, I had enough of project and deadline and schedules and all that crap, and also the managers, right? And I became developer advocate. So I was fired this summer because money. And I started on Monday. And so I work now for a company called Loft Labs. Does anybody know Loft Lab? Nobody, great. Please. No, that's really nice then, because now I need to have you to click a lot on the website so that I can come next year again. So if you are working with Kubernetes, we do virtual clusters. And if you are a regular dev, we do native dev environments like cloud spaces, but open source. That being said, I have experience. Some people might say I'm old, but I prefer to say I have experience. It looks much better. There was no such thing as observability. People did monitoring. And monitoring was just a bunch of people looking at screens all day. And if something happened, like on the dashboard something would happen, then they would try to intervene and fix the situation. That's what we called alerting in the day. There were no pager, no nothing. It was a bunch of people like sitting. But the problem with that approach is that the system become more distributed. So it's not possible anymore to just look at the screen and say, oh, there is an issue. Okay, there is an issue, but it's not enough. We must find the issue where it is. And that's the reason why we came with the term of observability. So I'm a big fan of using Wikipedia definitions, whether they are good or bad. They're always interesting. And this one mentions logging and tracing, but of course, the most important one is the metrics. So pillars of observability, metrics, logging, and tracing. This talk is focused on tracing, but I need to mention metrics and logging because it's a part of the whole. The metrics, I believe everybody does metrics. Everybody. If you are not doing metrics, probably you are already out of business. You just don't know it yet. What I would advise you is to move from like low-level metrics, because the business doesn't care about your CPU usage. Believe me, they don't care. They are interested in the number of orders per second or the number of HTTP response status in the last hour, this kind of stuff. So you just keep your whole infrastructure and you just bring them like higher level metrics with business value, and they will be your best friends. Logging. Logging. I had a talk dedicated to logging a couple of years ago. It seemed like it's a very simple subject. It's unfortunately not. The first thing is what to log. So when I was a young engineer working on the JVM. Is anybody working on the JVM here? A couple of hands, okay. And I thought, oh, I will be smart. Logging is very boring. It doesn't bring any value. Nobody does it right. I will create an agent, so I will instrument my code. So every time the JVM runs a method, then I will log the input parameters and I will log the return value. And that would be very smart, and I will fix all the problems in the world. Well, I was foolish, I was young, right? Because I noticed afterwards that probably the password, you don't want to log it. And so, well, fallback is you need to do manual logging. It's boring, it doesn't bring any value, but there is no other choice. You actually, when you do a code review, you need to focus also on the log and not only on the algorithmic performance of maintainability of the code. The logging format is also something interesting because, again, in the past, something happened on your system, you logged into the machine, you read the log files, and then you say, okay, here is the stack trace, here is what happened. Yeah, guess what? Nowadays, the problem is you don't know which machine produced the log, where the problem happened, so you don't know which machine you need to log to. And worst case, it was a container, and it has already died, replaced by another container. So what we are doing is we are sending the logs to a centralized logging system. And guess what? It needs to index the data. And guess what? If you have human-readable log, then you need to transform it somehow into something that can be indexed. So why don't you just create JSON directly? Because nobody will read that log directly from the machine. Just create JSON format, and then you don't need one additional component that will transform the non-structured data into structured data. Third problem, where to log? I started my career, it was very, very bad to log on the console. Everybody had to write on log files. Now we are using containers, and files are a problem. It's much better to log on the console, and again, send the console log to the centralized logging system. So it changes from time to time. Then you need to think, if you are an architect, whether to scrap the log or to push the logs. I mentioned parsing the log. Then you need to think about how long will you need to retain the log, what kind of criticity different kind of logs might have. Like, do you need to have the logs in Kafka because you run a very, very important system and you need auditability for 10 years? Or do you send them to somewhere else? I don't know. I can't say. It depends on your context. And you need a system to search and to display the log. Here are a couple of systems that you might use. I'm more familiar with the Elasticsearch stack, but it depends really on you. Now comes the most important part, is tracing. So again, Wikipedia definition, which I don't like that much, so I replaced it with my own, and here I let you read it. So probably it was inspired by lots and lots of stuff. But I believe that saying that it's like to follow a business request, call all the components in your system, like matches the idea of distributed tracing. If you have done tracing in the past, there were some pioneers already, like Zipkin and Jaeger and OpenTracing. The problem is they were constraining your choices, because then there were proprietary systems, and if you had to choose another component and you were using, let's say, Jaeger, then you would say, okay, what component is compatible with Jaeger? And it would limit your options. So when you have this kind of issue in the industry, what do you need? You need a standard, and a regular standard. I don't know if you know the XKCD comic. Then somebody says, oh, we have like 14 competing standards. I will create a standard to unite them all. And now you have 15 competing standards. Who knows these comics? Yeah. If you don't know it, XKCD is really fun. You are not super discreet. So you need a strong governing body, a body that people trust, and not just somebody who says, oh, I will do this. And here comes the W3C. I mean, it's a strong governing body. It has trust. People believe in it. And so it came with a trace context specification. Who knows about this trace context specification? One person, 2 persons, perhaps 3? No. Okay, I encourage you to read it. It's quite readable. It's not this hard-to-read specification. It's not a research stuff. It's very straightforward. It's about 20 pages. So I read it for you, and here is the summary in one slide. It defines 2 important things. It defines 2 abstractions. The idea of a trace, and the trace is actually a business request that gets executed through multiple components, and the idea of a span. And a span is what happens inside one of those components. And how does it work? It works through a HTTP header, which basically gets like read, change, and pushed forward. That's super easy. So if you have more a graphical understanding of things, here is it. It is. This is why I wanted to use my own pointer. So I have a single trace, and I have 3 components, and I have something that happens in component X, and I have something that happens in component Y and Z, and the spans, they are related in a child-parent relationship. So a parent can have multiple children, a child can have one single parent. It's easy, right? It's not really complicated engineering. That anybody can understand that. So how would you do it? Well, I mentioned it. You take the HTTP header, you create a new span ID, you say, okay, this is the span, the parent span, this is the trace, and you push forward. Well, we are engineers, we are developers. I assume most of you are developers, meaning we are pretty lazy by definition, right? Who is lazy here? Okay, who prefer to say they are optimizing their efforts? Which is the right way to say it. If you say you are lazy, it doesn't look super great. You are optimizing your effort means you are very smart. Then, because of that, we probably want a library that does it for you. And here comes OpenTelemetry. And OpenTelemetry does a lot of stuff related to logging and metrics, which I won't touch here, but it does stuff related to traces, which is what is interesting to us. And in that regard, it gives us libraries and frameworks and tools to work with traces. So it implements the W3C trace context. I will show it afterwards. Who voted on, I asked how many, who would be interested in which technology. I saw 3 votes, so you are not using the WOVA application. I will take the name of the people who voted and tell Eva they are good people, all others very bad. OpenTelemetry is the merge of open tracing, which I mentioned before, and open census, and that is rare enough in the open source or even in the software development world to mention. It was a success, and now it's a CNCF project, Apache V2 license. I don't know. The numbers are not relevant anymore, but it's still very, very good. And I like to say that OpenTelemetry is like a black hole that it attracts every actor in the telemetry industry. Like everybody knows must be OpenTelemetry compatible. It's very easy to also to provide OpenTelemetry stuff. Basically, you have your sources of data. They can be like very different. It can be infrastructure, it can be your own code, it can be whatever. And it sends data in a very specific format through a very specific protocol. And then on the other side, there is something called the OpenTelemetry collector. OpenTelemetry provides such a collector, but is just for you to transform and filter and perhaps merge data, but it doesn't care about it as long as you send the data in the format that OpenTelemetry is defining. In the end, it's up to you to define what kind of database, how you would actually store the data. And the good thing is, if you are already using Jaeger and Zipkin, OpenTelemetry, they are both now compatible with OpenTelemetry. Meaning you can keep your infrastructure and say, okay, I will open a new port on which it will receive OpenTelemetry data. Then you start to send OpenTelemetry data, and at that point, it's good because you are using a de facto standard, and you can just say, okay, now I will replace Jaeger with Zipkin or with anything else, and you keep your whole infrastructure. So I believe it's really, really great. Now comes the hard part. How do you start with using OpenTelemetry? I assume most of you are developers. Who here is a developer? Yes. Who here is a ops person? Okay. And who is a DevOps, whatever that means, because nobody knows? Okay, great. So I will talk to developers. If you are an ops or DevOps people, then you let them know about this presentation, and they will help you achieve like a better observability of the tools that you are operating. Basically, you have two approaches, and they depend a lot on your tech stack. The first thing is, do you have a runtime? That's the most important question. Like, if you are on the JVM is a runtime. If you're using Python, Python is a runtime. Node.js, runtime. Rust, Golang, no runtime. If you are in the good position to have a runtime, you can use auto-instrumentation. So on each of those different stacks, you will have interceptors that will change the way the code is executed at runtime. On the JVM I mentioned, it's called an agent. And in that case, it's very easy. You just use the agent. You were not fast enough. Like this, better? Yeah. I need to stop doing that kind of stuff because afterwards I lose my train of thought. So if you have a runtime, you use auto-instrumentation, it's easy, and more importantly, your developers, they don't know they will use OpenTelemetry. They don't need to change anything, right? They keep using their code, and at runtime, you add the agent, it creates the OpenTelemetry data, and you are happy. If you want to have more detailed or more control over the traces and the spans, or you have no runtime, well, just go for the manual instrumentation. If you can, just use auto-instrumentation. My experience is that observability, in general, traces, you go to the business to ask for money, they don't care about that crap. For them, it's just that it doesn't give you any business value. Okay? So it will be hard to get budget. You start with auto-instrumentation, it costs nothing, it's just something at runtime. You do like dark IT, you put an OpenTelemetry collector in the corner, and then you start collecting the data, and now comes a bug, because there will be a bug coming like every time, and you use this OpenTelemetry data to fix it. And now you come to your manager saying, look, this is how we fix the bug. Now give us money to have a regular, good project. And I believe that it can work. So, auto-instrumentation for the win. And now I've talked a lot. I will do a little demo. I mentioned I'm a developer advocate, right? So developer advocates are the kings of the Hello World demos. Yeah, it's just stupid stuff that anybody can hack. Well, it's a bit more involved than Hello World. A bit, right? So I've worked in e-commerce. I love these e-commerce examples because they are really great illustrations. So here I have, I will say a bad word, a microservices application. You probably shouldn't, but many people are saying, oh, it's amazing. It's very good if you are in the microservices application. Distributed tracing is just a requirement. So here my user comes on the first page of my e-commerce application, and I want to show them products with their prices and availability. I will filter out products that are not available. So first, they use this API. I have an API gateway that forwards them to the catalog. The catalog asks for the stocks. And you see every one of them is in a different technology. So I will need to vote for the one that I want you to show, you want me to show you the samples of. Here I have another component, and this one is through GraalVM. So basically, I have Kotlin code, we're using Spring Boot as well, but I compile it not to bytecode, so I won't have a runtime anymore. I will compile it to native code. I have this Golang stuff. I hate Golang, but everybody seems to love it, so I put one. I have this Ruby stuff because, well, it's still a thing, perhaps. Pricing is done in Python with Flask, I have caching every one of the services. They store their data in a database, in a Postgres database, in isolated schemas. I didn't put it on the schema because that was already too much. But here I have Redis just to cache the prices just in case. And because I got lots and lots of people asking me, yeah, but you know it works on an HTTP header. What about asynchronous messaging? What about Kafka? What about MQ? I put one example. So the catalog will actually push data into the MQTT broker, and I have an Node.js application that subscribe, and it will be part of the trace. Amazing, right? Yeah, no, it's not amazing. Somebody is, hey, who are you? It's not amazing. It's too much. You can't please everybody. Okay, let's start. I will start small. I will start with these initial commits, and I will Docker Compose. I'm using Docker Compose yet because, well, I started on Monday, so I couldn't move everything to Kubernetes, but this is how it looks. Everybody is familiar with Docker Compose, right? I just described the container. So I'm using Jaeger. It's not to say don't use Zipkin. It's just because it's super easy to use. I just have one single environment variable, and now it becomes OpenTelemetry compatible. I love it. I have, as I mentioned, I have an API gateway, because you should always have an API gateway. And I have the catalog, so this is a regular Kotlin on the JVM stuff. I will be using a Java agent. This is the pricing, as I mentioned, is fast Python. Inventory is in Rust, because I love Rust, even though I'm not super great at it. This is Golang. I hate Golang, but everybody seems to love Golang, so I said, okay, let's have one. This is the GraalVM native stuff that I told you about. This is the Ruby one, and as I mentioned, Postgres and Redis. So I will do a query. I will just do this query. And this is the result. I will. And this is the result. Thanks. And every one of them contributes to the trace. So I have the API gateway here. Before, in my previous presentation, I used API 6 because I worked on the project. Now I replaced it with CrackIndy. You can have the same stuff. I have the catalog. I have the inventory. I have the stocks. I have everything that I want, right? And here you can see I will do a get. So here, every span has additional metadata. So here you can see this is the DB statement. It will get stuff from Redis, and probably because the cache is empty, well, it's not probably, the cache is empty, so it doesn't find what I want. It does a call to the API gateway that forwards it to the pricing, and at the end, again, I have the set, and you can see now the price is cached. So if I do it again, if I do the same call, you can see I have less spans, and probably here it's because it doesn't call the pricing. It does directly, get the data from the cache. This is just observability to you. You know nothing about the system. You can compare the two traces, and you can see, oh, there is a difference here. In this case, I called the pricing. In this case, I didn't call the pricing. So even if you know nothing about the system, you can actually understand some of the thing, what happens. But what's more amazing, I told you about auto-instrumentation. So I asked you who is a JVM developer, and look, this is how I told my developer to use OpenTelemetry. Zero dependency, so I'm sorry, this is a POM, because Gradle is governor. And no dependency on OpenTelemetry. Nothing, zero. What I did, so here I'm using containers, but normally it would be a runtime. So this is a multi-stage Docker file, right? So first thing, I'm compiling to create the package, so the jar, and the second one, I'm running it on the GRE, so the first one GDK, second one GRE, and this is where the magic happens. At here, build time, but if you are not using container, it will be runtime. Then I download the OpenTelemetry agent, and I run with the OpenTelemetry agent. This is the only thing that I had to do to make the catalog contribute to the OpenTelemetry trace. Who here is a Python user or Python developer? Wow. JavaScript? Wow, okay. That's a lot. Okay, Rust? Yeah, come on, be proud. Yeah. 2 people, okay. I will show Python, I'm sorry. Everything is on GitHub at the end, so don't worry. So Python is the same. Python, I'm using Poetry, I didn't use UV yet. That's all my dependencies. Again, nothing that is OpenTelemetry related. However, when I create my image, then I add the dependency, I install all the dependencies, and more importantly, I'm using, now that the OpenTelemetry dependency is installed, I have access to this command line, and this command line allows me to install every OpenTelemetry dependency that has a dependency in my application. So for example, you can see on the trace, on the first one, that I'm using here. I'm receiving a request, and here that it connects to a DB. And I didn't do anything. Why? Because there is an OpenTelemetry Postgres driver that knows, okay, here is using the Postgres driver, so I will add the dependency that is OpenTelemetry Postgres driver. And this is just amazing. And as I mentioned, at this point, it costs you nothing. You just put an OpenTelemetry collector in a corner, your boss doesn't need to know about it, and you start collecting data, and it can help you. But probably at some point, we will need more control, or if you are using Rust, for example, Go, who is using Go? Please don't raise your hands. Okay, nobody is using Go. That's what you are good people. You will check the stuff yourself. But on the Rust side, then there is no runtime, and indeed I need to myself add the dependency for OpenTelemetry. I'm using the XM framework, the thing that does the async stuff on Tokyo. And basically, you need to have the OpenTelemetry stuff, tracing, blah, blah, blah. And because I'm using XM, I'm using stuff from the community, which breaks at every minor version. So here you can see that I didn't upgrade it, because after 18, I had issues. It didn't create the traces, and I was too lazy to actually find the problem. So that's the problem with if you don't have a runtime, and especially in that space. Otherwise, the rest is just the same. Because I'm using XM, as I mentioned, then instead of being an agent, you can have these, like, how it's called, the tower services. So here I'm just adding the observability there, and it's just good enough. Sorry, here. The layers are here. And then on each route, then I don't need to care about OpenTelemetry. So it's just a level of abstraction down, but you can still manage more or less the same. Now I will do manual control, and I have 6 minutes left, so I will need to be very, very fast. And I need manual instrumentation. I will show you the differences with Java and Python. And it takes time, blah, blah, blah. And I was too fast. And it works. Okay? So so here I had, how many? I had like 21 spans. So here I will add a bit more, 25. No, don't compare them, please. 25. I added one additional dependency on the Spring Boot side, which is annotations. Annotations, not this one. Yes, this one. Okay, which allows me to add annotations in my codes. And here, I added this with span stuff. Previously, these functions were not observed, but now I'm saying, okay, please observe them. And by default, they will have the name of the unqualified class name plus the name of the function. And here you can like override it. You can also add by yourself additional data. Here I'm using the product ID because in such an architecture, I might have discrepancies saying, okay, I'm asking for product ID X for the pricing, but it returns the price of product ID Y for whatever reason. So I want to be sure that the ID matches. So here I will have an additional one. So on here, the fetch product details, and I don't find it because I'm too far away. This is fetch. It's called fetch. It's here. So here I am having the product ID 1. This is I manually added. And on the Python side, it's different because here now I'm using the OpenTelemetry distro, so I added explicitly. And on the app side, I'm using the API, and I say product ID whatever. So here, I'm just missing on the pricing side. Where is the pricing? Here. I'm just missing the product ID here. So I need to go even further, and I need to add the manual API. So I will do two things at once. I will add the asynchronous stuff. I have 3 minutes. I need to be very, very fast. But you were late, so I will take a couple of more minutes. And then I'm upping it again. And now on the Spring Boot side, when I receive the requests, I will have a filter. And this filter, so here it will be here. And it's on the, here I will have this filter. So every time I receive a request, I will have this analytics filter. This analytic filter will actually get the HTTP header, right? And called transparent. So now is the time where I need to actually concern myself with the implementation, which I didn't do before. I just used the libraries and I was super happy. And now I need to do that by myself because currently there is no library that does what those library does for HTTP for asynchronous work. So now I get the data and I store it as metadata inside the MQ message. If you are blocked at MQv3, I think, then there is no metadata. You need to send it along with the payload, which is less clean, but well, you have no choice. If you have 5, then you can use it as metadata. On the Python side, I'm getting back to the Python side, so I can do things like this. I can add the attribute, the product ID, and then we can match that actually. I get back here. Did I do the traces yet? No, I didn't. Okay, so even more traces. Here we can see that the product ID now, I have tagged it, and it's here. And I have product ID 1. So I can check that there is no discrepancy between the product that I'm requesting and the product that is returned. This is the kind of thing that you can do. I was mentioning the analytics, and here you can see there is this little thing, read message. So on the analytics side, I'm 1 minute too late. You stay there, don't move. I see you, be careful. I see everything. This is what I'm doing. I'm doing the complete opposite. I'm reading the metadata, which is stored in user property, and from this metadata, I'm actually reconstructing the context. And from that point on, I'm able to use the API on the JavaScript or TypeScript side. There is one slight issue with that, is imagine you stop the analytics, Docker Compose stop analytics. Then I can run it again. And it looks like this. So now I have, of course, there is no analytics yet because it isn't part of the trace. And I can start it again. What doesn't work, even in Croatian, in Serbian, sorry. Stop the recording. Don't kill me, please. I'm a good guy. It's the same language, right? Did I trigger anybody? And here is this one. Yeah, that's the problem. Now, because it's asynchronous, then all the synchronous stuff is on the left and is like compressed, and the other is here. So depending on the software that you are using, you can filter out or just, it doesn't work that well. Let's say, yes, this kind of stuff. So I need to refresh it and do things like this, perhaps like this. Yes, and now you can see it again, and of course the analytics is like somewhere here. So now you have other issues, which depends on the like display software that you are using, but you are still in a very, very good situation. So thanks for your attention. I won't stand between you and lunch. You can follow me on Twitter, even though I think that it's dead now. You can follow me on Mastodon or Blue Sky because I have no clue, and it's not the right link. Look, I will do it in real time, bit.ly. It doesn't work. Okay, don't worry. I will give you the direct link. It's github.com. That's, you know it, right? GitHub and Frank, and it's called OpenTelemetry tracing. Okay, so I won't be able to track you, which is sad. So everything is on the everything that I've shown, and even more is on the GitHub repo. And if you want me to come next year, please visit loft.ch from a Serbian IP. So I can show my boss that I was here, that I told you about the product, that you are convinced you will buy it or whatever. Thanks a lot. I have no time for questions.